All right, last topic of this chapter. So, but this one going to be a little bit more detail about the reaction enthalpy or the enthalpy of reaction or the heat of reaction. They are the same name. Anyway, so we have seen that the ethanol, combustion of ethanol release energy, right? And the dissolution of ammonium nitrate that's absorbed in this reaction absorb energy. Okay, so the enthalpy of reaction relates by the number of moles in the balance equation. So all the mole like 1 to 3 to 2 to 3 right here. So if you look at the first equation here, this first equation means if you burn or do combustion on a 1 mole of ethanol, so 1 mole of this, you will produce 1,368 kilojoule of heat. Okay. If let's say you use excess ethanol, but you use 3 mole of oxygen, same thing, 3 mole of oxygen produce that the same number. Producing 2 moles of carbon dioxide require that heat coming out, right? Producing 3 moles of water, also this reaction will produce the same amount of energy. So it's per mole, right? Per mole of the coefficient of each species in the reaction. And here's how, this is what I mean. Let's take a look at the application. Many manufacturers produce hydrogen gas from methane gas. So we have methane gas, react with water at high temperature to produce a hydrogen gas as in reaction below. This reaction is endothermic, so positive number, okay? And how much heat energy is required to produce 1 kilogram of hydrogen gas, okay? So according to the reaction, to produce 3 mole of oxygen, that energy is required, all right? So the question asks the energy required in kilojoule per kilogram, 1 kilogram of hydrogen gas, right? So what we have from this reaction, that energy is required to produce 3 mole of hydrogen. To produce 3 mole of hydrogen, that energy is required. So your job is to convert moles to kilogram. That's it. Nothing different there, nothing difficult here. All right, moles to gram first. Put moles at the top, grams at the bottom. Mole cancel out. And then grams at the top, kilograms at the bottom. Okay? Do the math there. You get that number. Move the decimal. 1, 2, 3, 4. 3.4, blah, 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 times 10 to the 4th. 3 sig fix. Make it 3 sig fix. That's 4. That's so weird. 1, 4, 6. Supposed to be 3 sig fix. 3.40 times 10 to the 4th kilojoule per mole. Okay? A kilojoule per kilogram hydrogen gas. All right, your turn. One more time. All right? Acetylene, C2H2, react with hydrogen gas, this guy here, in the combination of reactions shown here. How much heat energy is released if 501.6 grams of hydrogen gas react with excess acetylene? So this guy excess, don't care about it. 501.6 grams of hydrogen gas. Okay, so from the question asks for the heat release total. From the equation, 2 moles of hydrogen gas release that much energy. Right? 2 moles of hydrogen gas release that much energy. So the question asks, what if you have only 501.6 grams? That's much more. 501.6 grams of hydrogen gas. How much energy will be released? Well, convert moles to grams, right? So put moles at the top, grams at the bottom, and then we have that grams right there. So times grams. So they all cancel out. Mole cancel out. Gram cancel out. Do the math there. You should get that number much higher, right? Move the decimal. 1, 2, 3, 4. Get that. That's kilojoule per mole and 4 sig fix. Supposed to be 3 sig fix. I don't know why. What happened to me? Negative 3.87 times 10 to the 4th kilojoule. Okay. All right. Lastly, so go back to gasoline and ethanol. So we saw that the enthalpy of reaction or combustion of ethanol is produce less energy than the octane. This is the gasoline. Okay. Convert this into we did this together. Convert into a kilojoule per mole, 2 kilojoule per grams. Same thing. Octane produce higher energy than ethanol, right? Which is do in per gallon. So that's a there's a selling price per gallon. So per gallon, octane produce that much energy. Ethanol produce only that much energy. If you do the math there, octane contain 43% more energy than ethanol, the same amount of ethanol. Okay, so but in reality, so we mix ethanol and gasoline, so we call gasohol. So if you go to the gas station nowadays, you might have seen E30 or E15, which means that this gasoline contains 15% of ethanol, 30% of ethanol. Okay, and you can guess that 30% of ethanol is cheaper because ethanol is cheaper than octane. All right. Okay, all right, one more. So class activity number 5, and this is the last slide of this chapter. So I'll see you again on in chapter 9. Bye.